In section 1.4, we are using tables, equations, and graphs to represent functions. We will use one representation to be able to produce another. Starting with a table, we can recognize that we have a set of inputs and a set of outputs. Remember, this is a relationship because your input maps to your output. The most common way to represent a table is with ordered pairs that can then be plotted on an XY coordinate grid. So this first pair is 0, 3. The second pair is 1, 4, 3, 6, and 5, 8. Remember that the first number is always your input or your X coordinate, and the second number is always your Y coordinate or your output. So from here, we can plot these points. So 0, 3, if X is 0, I stay right here, and Y is 3, I move up 3 units. When X is 1 and Y is 4, if X is 3, Y is 6, and when X is 5, Y is 8. So I now have a representation of this function using both a table and a graph. In this next example, we can use an equation to produce a table and then use that table to create the graph itself. So notice our domain are the X values of 0, 4, 8, and 12. So I need to use these 4 numbers, evaluate them in my equation to produce the corresponding outputs. So we'll start with 1/4 times 0, and that gives us an output of 0. When the input is 4, we get an output of 1. When the input is 8, we get an output of 2. And when the input is 12, we get an output of 3. Once again, notice I'm using the same equation each time so that I can map my given inputs to their corresponding outputs. And from here, I can go ahead and plot those points. So 0, 4. Sorry about that, I made a mistake. So it should not be 0, 4, it should actually be just 0, right? Because anything multiplied by 0 is 0. So let me change that. And now my pattern seems to make more sense as well. So plotting the point 0, 0, and then 4, 1, 8, 2, and when X is 12, Y is 3. In the third example on this page, we're given a context telling us the table below shows the average score M on the math sections of the PSSAs from 2006 to 2011 as a function of time t in the years since 2006. So we want to use this table to graph the function. So notice instead of using X and Y, I am using the variables t and M. However, we've defined that t represents the horizontal axis and M represents the vertical axis. So in this case, I would be plotting these numbers in this order. So for example, when t is 0, M is 68. So my first point at 0 and 68 is about right here. When t is 1, my output is 73. So remember, this point represents actually the year 2007, and it represents a score of 73. So at 173, that's about right here. The next point is 274. That's going to represent the year 2008, since that's 2 years after 2006. 377. So when T is 3, M is 77. When T is 4, M is 78. And when T is 5, M is 82. So once again, just taking one representation of a function/relationship and creating a new representation using that information. Lastly, we can use a graph or a table to create a rule, or we could also call it an equation to represent a function. So in this first graph right here, I'm going to write these ordered pairs into a table. So this first point is 1, 1. This second point is 2, 3. This third point is 3, 5. 4, 7. And 5, 9. So whenever we're writing an equation, we can think about a pattern that is being followed. So take a moment to look at this table, and can you find a pattern that is occurring? So hopefully you recognize that as the x value repeatedly increases by 1, the y value is actually increasing by 2 each time. And if you recall, when we are repeatedly adding the same number, we can represent that using multiplication. So that actually tells us that we're multiplying our input by the number 2. But you might say, Mrs. Lease, if we're multiplying by 2, shouldn't this output be 2, since 2 times 1 is 2? Yes, however, there could be another operation that's occurring. So notice if I multiply 2 by 1 and my output is 1, then the other operation that is occurring is that I'm subtracting 1 unit. Now, we do have to confirm that this always works. So when my input is 2, multiply that by 2 and then subtract 1, I get an output of 3. Okay, that works. When my input is 3, if I multiply that by 2 and subtract 1, my output is 5. That works as well. And then we can also see that it works for these last two pairs. 4 times 2 minus 1 is 7. 5 times 2 minus 1 is 9. So that tells us that if we multiply our input, aka x, by 2 and then subtract 1, we will always get our output in this function. And this ends up being the rule/equation that represents this graph and this table. Take a moment. You're going to pause the video and try these two on your own. You're going to be graphing this equation with the domain. Remember, that's your x values of 0, 1, 2, 3, and 4. And then trying to write a rule for this function. Something I want you to think about, how does the y value change as the x value changes? And what is your starting point? So go ahead and pause the video, try it out, and then hit play to see what the answers are. For this first problem, I get the following outputs given my domain, and those were all calculated using the equation y equals 3x minus 2, and then I went ahead and plotted them on the graph. Notice the first point, 0, -2, does not quite fit. I did just draw that down here just to give you an idea of where it would go. But notice there is a pattern within our points, and that's due to the fact that we have an equation that maps our inputs to our outputs. Notice in the second question, we can create a table based off the points in our graph. Now, the y values are actually increasing by 0.5. So we're adding 0.5 each time. So remember, as I said up here, when you're repeatedly adding a number, that's the same as multiplication. But we can actually use this very first point of when x equals 0 to help us out, because anything multiplied by 0 is still 0, but we need to get an output of 2. So that tells us that we have to add 2 to 0.5 times our input to get the proper outputs. And if we check each point, we can see that that works. So 0.5 times 1 plus 2 is 2.5. 0.5 times 2 plus 2 is 3, and so on and so forth. So the equation of y equals 0.5x plus 2 represents this graph. In summary, we can use equations/rules to create input-output pairs, and these pairs can then be represented as tables and as graphs. Make sure you are completing the circled questions in both the practice section and in the application section. Notice some problems that aren't circled are answered for you, so you can reference them as well if you need help. Lastly, make sure you're taking a picture of these questions and uploading them to Canvas for the assignment this week.